I just wanted to talk to you guys about some of the work that I was doing for my master's thesis on the horseshoe crab spawning in the Delaware Bay and a potential response to sea surface temperatures. So the Delaware Bay is situated on the east coast of the United States and has the largest spawning populations of horseshoe crabs. As they spawn in their greatest densities between May and the second week of June, the high egg abundances on the coastline are a very valuable food resource for migratory shorebirds. Although tidal cycles play a role in synchronizing the events for spawning, temperature has been shown to either advance or delay this event to coincide with more suitable environmental conditions. Unfortunately, many studies only look at temperature using one or two of the buoys in the area that may not be representative of the entire Bayshore area itself, making identifying a true temperature threshold difficult due to spatial constraints. Thus, identifying the peak spawning temperature is important for understanding their behavior during anomalous years when waters are either warmer or colder. So sea surface temperatures have a satellite record dating back to 1981. However, the spatial resolution has either been too coarse or obscured by cloud cover, as you can see in these black areas. The buoy record predates satellites. However, measurements have a limited spatial component, and they may have missing data from technological malfunctions, maintenance issues, or discontinued use. The multi-scale ultra-high resolution sea surface temperature dataset on the right here provides a daily sea surface temperature snapshot with a spatial resolution of 1 kilometer and is currently extends from June 1st, 2002 to the present, and basically allows you to infer large-scale sea surface temperatures such as the Gulf Stream and here, or small-scale features that you would be able to see in coastal regions. This is accomplished by blending observations from satellites, buoys, and ships using the multi-resolution variational analysis with an accuracy of 0.4 degrees Celsius to the foundational sea surface temperature that traditional buoys measure. This allows larger areas of sea surface temperature to be identified over geographic areas or for sites that may have limited observations from buoys, such as in small coastal areas in the Delaware Bay. So utilizing the MER dataset, we collected data from April 25th to July 3rd for the years 2003 to 2019, and we created weekly baselines for the 17 years worth of data. This aggregation was also then completed for individual years between 2015 and 2019, when sampling occurred for spawning horseshoe crabs to identify periods of anomalous sea surface temperatures and how horseshoe crabs may have responded to them. Daily observations were also used to identify average sea surface temperature on the day of sampling to better understand temperatures within and between regions when sampling occurred, providing higher spatial resolution than a single buoy. And a 5-day moving average was also computed using this data set to look for long-term trends. The sea surface temperature and its 5-day moving average were used to identify the peak temperature threshold upon the horseshoe crab sampling data collected by Dr. Joseph Smith at the New Jersey Fish and Wildlife Center. The horseshoe crab egg data on the surface and as clusters were collected as a way to determine if the temperature threshold was consistent between these two sampling, along with clusters were sampled for approximately 1 month longer. The methodology that we used to determine the threshold for spawning horseshoe crabs was a cart analysis. This methodology is ideal for ecological data sets that include continuous and categorical data, missing values, and numerous independent variables to grow decision trees through machine learning algorithms. It identifies how best to split the data based upon the variables used into more homogeneous groups. However, due to their ability to overfit a data set from the training data used, you must prune it to improve the accuracy for testing data set. So in this case, we have data that's inputted into the model, and then if it meets that criteria, it will go left into a intermediate node. If it does not meet that criteria, it will go right into a terminal node, and this will continue until all the data sets are classified into terminal nodes. The baseline sea surface temperatures, as seen on the left, increased from approximately 10 degrees Celsius to 25 degrees Celsius from week 1 to week 10, but in 2016, cooler anomalous sea surface temperatures existed, particularly in the early weeks of May observed on the right. Even when a possible warming bias is in this data set due to the majority of the warmer years on record being within this time range, cooler anomalies of sea surface temperatures were identified, particularly in the early part of the spawning season. Because of the lower sea surface temperatures that were present in the area, horseshoe crabs were observed to delay spawning by several days and peaked in week 6 when sea surface temperatures were warmer in the Delaware Bay area. Despite warmer than expected sea surface temperatures in weeks 1, 2, and 8 in 2017, as seen on the left, much of the spawning season is what one would expect, particularly between weeks 2 and 5, which is the early part of the spawning season. Warmer than expected sea surface temperatures were present in the Bayshore area in 2018 on the right, particularly in the early weeks of the spawning season, resulting in the advancement of spawning to the earliest time periods in the study in weeks 4 rather than what one would typically expect in week 5, which has severe implications for migratory shorebirds that may not be in the area yet. In the card analysis, the most important variable we used was a 5-day moving average for sea surface temperatures. After pruning the tree, the best way to determine if the spawning period is before or after peak is when the 5-day moving average for sea surface temperatures reached or exceeded 17 degrees Celsius with an accuracy of 81.4% for horseshoe crab egg clusters and 80.4% for surface eggs. This suggests that when sea surface temperatures reach 17 degrees Celsius, temperatures are optimal for large-scale spawning to occur, allowing the species to synchronize spawning around temperature and not static cues like lunar phases. The advancement of this threshold was also observed in all 3 geographic regions of the study, so the northern region, the central region, and the southern region. But it was most pronounced in the northern region by several days. As this threshold has advanced, it is important to monitor how this advancement continues to change into the future. 2003, which is indicated as the green circles, and 2012, which are indicated as the red circles, stand out as outliers in this analysis and are worth some further discussion. In 2003, it was the coldest year in the data set and was roughly 3 degrees Celsius colder, resulting in the threshold not being met until June 23rd, with the peak spawning observed on June 14th. In 2012, sea surface temperatures were approximately 3 degrees Celsius warmer, resulting in the peak spawning to occur on May 22nd. This threshold advancement is concerning for migratory shorebirds, as an ecological mismatch may develop between horseshoe crabs that are spawning earlier to meet this new threshold and the arrival of shorebirds not changing, which could deleteriously influence many of these shorebirds populations, which are already threatened or endangered. This work has shown that the MEaSUREs MUR sea surface temperature data set provides comparable measurements to buoys, especially in the coastal zone. Horseshoe crabs in general synchronize their spawning around temperature, resulting in the largest spawning events when sea surface temperatures are approximately 17 degrees Celsius. This holds true for all regions in the Delaware Bay, but not necessarily all locations on the East Coast where they do spawn. Lastly, this threshold has significantly advanced since 2003, raising concerns of the potential development of an ecological mismatch between migrating shorebirds and spawning horseshoe crabs, but requires more work to clearly identify if this is occurring. I wanted to thank you guys for everything. It was a really great experience,